you are stuck with that old mindset where you might not be learning new things. So definitely A is going to replace you. It's similar to saying that, okay, back then people used to have, what do we call it? People to even jot down notes and stuff on the notebook. Now we have a computer which simplifies everything. So with the passing time, definitely AI is going to replace a few jobs, but it's like, within, if AI is replacing software development, there are new fields going to be emerging within the world of computer science, like quantum computing, emergence in cybersecurity, where you definitely could be going. So AI is going to take the software engineering job where if you are only relevant to software development. But if you study computer science and study computer science in a way where you're not only focusing upon developing a website, but rather looking into what's not explored, like 10-15 saal pehle, like literally 10 years ago, if you would have told a random person that there's going to be something like Chat GPT and Claude, where you're going to talk to them and you're going to tell them कि किस तरीके से ये कर लो वो कर लो, तो do you think they are going to believe कि यार wow ऐसे कोई चीज हो सकती है? They might be thinking ये तो जादू है. That's not possible, right? Similarly, there are domains of computer science which haven't been explored and are currently in research phase. If AI is going to replace software development, then we're going to have those newer domains coming up. We're going to jump into those where AI is not capable of that much work. So you do have a new set of demanding jobs coming up. So don't worry. It's just like if you have this thing in your mind, you make those languages seek and I would be good to go for life. No. You have to keep on learning if you want to be in the world of computer science, and you will be, inshallah, good to go. All right, assalamu alaikum everybody. I hope you all are doing super well. So welcome to the class number 3rd, or perhaps the last demo class. We are going to be starting off right now. We were just waiting for Sir Abbas to end his class because we were like, "De dena chahiye moka," right? Sir Abbas is one of the goated teachers out there for physics. So first and foremost thing, I hope you guys are enjoying the classes. If anybody of you might have missed out the demo classes, you can check it out on our YouTube channel up here at Code Catalyst. Just search it up and you're going to get the channel, inshallah, on the top. And yep. So first thing, in the last class, we had a pretty good discussion over the 3 types of languages, or like the number systems your computer understands. We studied binary, we studied denary, and then we also studied hexadecimal. For the O-level kids, again, I know this might be something aap log ko aata hai, but stay in the class and revise why something is happening, because we're going to jump into a few new concepts very soon, inshallah. Okay, so in the last class, we had a discussion over how you might want to go from binary to denary, and we also studied how you might want to go from denary to binary. Then we studied how you might want to go from hexadecimal to binary. And right now we're going to be studying how you can go binary to hexadecimal. And then of course, denary to hexa and hexa to denary. Okay, so how do you go from hexadecimal to binary? You split them, you convert each of them to its subsequent binary. If a value is 10 or greater, you use this table, you get those separate binaries, and then you combine the binaries together to get the answer. So if you have to do it from binary and you want to go back, it's, to be honest, the reverse of the whole process. How? So we're just studying how you might want to go from a binary to hexadecimal. Binary to hexadecimal. So if you want to go from binary to hexadecimal, you may be thinking, sir, ye to काफी complex hoga, ab main kya karunga? But no, let's take a binary number, 1101 1011. I just took it random. Okay, khud se ek number bana diya. Now how are you going to convert it? The steps behind converting from binary to hexadecimals are pretty straightforward. Step number 1, you make groups of 4. Make groups of 4. When I say groups of 4, what do I mean by this? I mean that you separate these numbers into char ke groups. So maybe this is one group of 4. This is another group of 4. So we have them divided into 2 groups of 4. And now you're going to count this separately. So you take this separately and you take this separately. So now we have 1101 and we have 1011. And now you're required to convert each of them back to the numbers. So like 1, 2, 4, 8. 1, 2, 4, 8. So this is 8 plus 2, 10, and 10 plus 1 is 11. But no, there's a slight problem. It gets me the answer as 11, but I cannot write 11, right? Remember, you cannot write 11 because हमारे पास तो representation 0 से 9 तक है. But if it's greater than 9, we study that we have a table that A is 10, B is 11, C is 12, D is 13, E is 14, and of course F is 15. We don't go above F when talking about hexadecimals. So if I look on to 11, 11 is basically a B. So I'm going to replace that 11, but rather with a B. So I get a B up here. And likewise, this is 8 plus 4, 12, 12 plus 1, 13. So 13 is a D. So I'm going to again have this place up here, and I'm just going to write a D up here. And then just like before, remember, we got the binary and then we combined them. Up here, you're going to get the hexadecimal values and you're going to combine them. And boom, you join the two together and you get your hexadecimal value as DB. That's the whole concept of how you might want to go from a binary value to a hexadecimal value. Let's do another example to further simplify and understand it. So for example, you have some value like 0011, 1011. So steps are, you first make groups of 4, 4, 4. So you now separate the two. So I'm going to separate this up here and this up here. So you get 0011 and you get 1011. Now write the values above it, 1, 2, 4, 8. And then you write the values over here, 1, 2, 4, 8. Convert them into the corresponding denary value. So 2 plus 1 is a 3. And this is 8 plus 2, 10, 10 plus 1 is 11. I cannot write 11 because 11 is not a valid hexadecimal number. But we know that if I want to represent 11, I can write it to be as a B. So I'm going to write that to be as a B. And now boom, you just rejoin the two together and you get the answer to be as 3B. That's how you convert a binary number into hexadecimal. But now before one of you comes up with a question asking, sir, what if I have a number where you cannot successfully make groups of 4? So for example, there is this binary number. So the first step is that you always make groups of 4, right? You make groups of 4. So if I want to make groups of 4 up here, you might start off from the most right hand side. Okay, I made a group of 4 up here. Remember, when it's binary, you start from the most right hand side. It's not going to be yahan se group banane. Always start from the right hand side. Start from right. This is an important tip, okay? And I'm going to tell you why. Because you start from the right, then you make one group, then you go to the other group. You start from here and you have a group up here. Perfect. But now you might be saying, sir, ye jo teesri value hai, this third value, that only has 2 values. But you said make groups of 4. Now what am I going to do? Now in a case like this, you're always going to add 2 empty zeros. Because we know that adding a 0 makes no difference, right? Like if I add a 0 up here, is that going to change the value? No, right? Because if I have to convert the value, 0 ki to value hum count hi nahi karte. Like we ignore it, right? So either way, it's just there to fulfill the requirement of making the group. Apart from that, it's going to be of no use. So now I have basically this. Now I'm going to separate each of them. I'm going to bring this up here, 0, 0, 0, 1. I'm going to bring this up here, 1, 0, 1, 0. And I'm going to bring this up here, 0, 1, 1, 0. And now each and every one of them, I'm going to separately convert them to its corresponding value, 1248, 1248, 1248. So you see the same zeros. They're not going to be added, right? Because it's a 0. Koi fark hi nahi padta. We just added them to fulfill the condition. So like this is 1. So I'm going to write this to be as a 1. This is what? 8 plus 2, 10. I don't know what's a 10. We know, but 10 is an A. So I'm going to write it to be as an A. And then this comes out to be as 4 plus 2, which is basically a 6. So I'm going to write that to be as a 6. And now I'm going to basically join the 3 together. And boom, that's going to get me my hexadecimal value as 1A6. That is how you basically go from binary to hexadecimal after studying going from hexadecimal to binary. So we did these 3 cases. You usually get a question just like this. It's never complex than this. I'm opening up the chat box. If there are any questions in understanding this, let me know. If not, we can then proceed towards conversion into denary. Any question? If not, then I expect every single one of you to send the word clear in the chat box. Perfect. Shabash, sub. 2 log ki clear mujhe nahi chahiye. This is O-level का टॉपिक, बट दिस इज गोना बी टेस्टेड इन AS. तो ये नहीं समझना कि ये AS में नहीं आएगा, ये AS का ही टॉपिक है, सही है? ये आप AS में आपकी एग्जाम में ये चीज आएगी. परफेक्ट, दैट्स ग्रेट. Okay, let's move on. So now we have studied how you might want to go from a binary to a hexadecimal, right? So if I come back here, we studied a few things. We studied how you go from hexadecimal to binary. So we studied this. We studied how you go from binary to hexadecimal. We studied how you go from binary to ternary, and we also studied how you go from ternary to binary. Right now, we're going to study how you might want to go from, my bad, you might want to go from ternary. Oh, bhai, सीधी, चलो इस तरह कर दो. Ternary to hexadecimal and hexadecimal to ternary. That is what we are going to be just studying. But if you focus, if you look onto the books have some crazy methods which are very confusing because you have to learn new rules and everything. And I don't want you guys to learn any rules or anything that's going to make the whole thing useless for you. And for that reason, I'm going to introduce you all to a shortcut. And what's that shortcut going to be? The shortcut is that rather than going from hexadecimal to ternary directly, what we're going to do is we're going to make smaller jumps. We're going to go, so I can write this up here, that if I have to go from hexadecimal to binary, to ternary, we know there is one direct method, but that's very confusing. मैं पढ़ाऊंगा भी. Why? अगर आप लोगों ने books में कहीं देखा है, डरना नहीं. It's just like one other way. But I'm going to make you guys an easier method. We know already how to go from binary to ternary, right? We know this. What if I say that rather than going from hexadecimal to ternary directly, we first shift the value from hexadecimal to binary, and it's super easy to go from binary to ternary. So you use the same exact steps which we just learned in today and yesterday class to go from hexadecimal to ternary. And this is fully accepted by Cambridge examiner. It's not like wo aapke marks kaatega. It's going to give you full marks. And I've been using this throughout my OA level. So it's perfectly fine. Don't worry with that. So how do you do it? Let's take an example. So for example, there is this binary number, hexadecimal number 6b. This is hexadecimal. So I have to first convert this into binary. How do you go into binary? Remember the steps? You split it up. So we have 6 up here. We have B up here. B is basically an 11. So now I'm going to convert each of them to its corresponding binary value. 1248, 1248. Write the corresponding value. It's going to be 0, 1, 1, 0. 4 plus 2 is 6. This is perfectly fine. And what about this? It's 11. 8 plus 4, no. 8 plus 2, 10, 10 plus 1, 11. So 8 plus 2 plus 1, 11. Perfect. And I'm going to merge the two together and I get my final answer to be as what? 0, 1, 1, 0, 1, 0, 1, 1. So this gets me the binary version. And now if I ask you to convert this binary number into ternary, is that difficult? What did we study in yesterday class? No, right? Just write the binary 0, 1, 1, 0, 1, 0, 1, 1. And write the corresponding values above it. Just the way I taught you guys yesterday. We'll shell for example. So you had the value starting from 1, 2, 4, 8. But this time, because it's combined, you won't be starting from 1 up here again. It's going to be like a combined. So it's going to be 1, 2, 4, 8. And then you're going to go 16, 32, 64, 128. And now I'm going to add the values of ones. So this plus this plus this plus these two. If I add them all up, it comes out to be as 64 plus 32 plus 8 plus 2 plus 1. So a shortcut for how to do these calculations, देखो कोई मिलता तो नहीं है. So 64, 32 plus 8 is 40. So 64 plus 40 plus 3. Okay, so 64 plus 40 is 104. 104 plus 3 is 107. So basically the answer I get up here is 107. Which means that if I have to convert 6b into ternary, you get it to be as in 107. That's how you go from a hexadecimal value to a ternary value. And in your book, there is another method which is very, very high error intensive method where there is a great chance you may fumble. There's a great chance you may mess up. And I don't want you guys to mess up at all. Hence, use this and this is perfectly fine. That's how you go from hexadecimal to ternary. And now if you have to do the exact reverse thing, if you have to go from a ternary value to hexadecimal, you have to just repeat the whole process. You don't have to do those complex 16 raised to power thingy which you might see in the book. That's useless. I don't want you to go through those division, those complex calculations where you might make an error. So what should I do? Easy. We know how to go from ternary to binary, and we just studied how to go from binary to hexadecimal. थोड़े से एक step बढ़ गया, but the chances of making an error are minimal, which means that you might not be inshallah losing marks on these easy questions. Which if you did lose marks on this question, फिर मसला है, क्योंकि फिर you are losing marks on easy stuff, and I don't want you to lose marks on easy stuff. So for example, there is a number like, let's say 75, and we are asked to go from 75 to hexadecimal. So first I'm going to convert it into binary. How do you convert a ternary number into binary? Bring up that same register in your mind, write it up: 1, 2, 4, 8, 16, 32, 64, and a 128. Fill it up so that you get 75. So this is going to be 0. 64 on ho jayega. So now I need to do 11. 64 plus 11 is 75. So 0, 0, 8 plus 4, 12 is 0. 8 plus 2, 10, 10 plus 1, 11. So 64 plus 8 is 72. 72 plus 2 is 74. 74 plus 1 is 75. So I got the binary as in 0, 1, 0, 0, 1, 0, 1, 1. And now you have to go from this binary to hexadecimal. How? You make groups of 4, and you make a group of 4 up here. And now you convert each of them separately. So this is like 1, 2, 4, 8, and then this separately 1, 2, 4, 8. So this is just going to be 4. So you write 4 up here, and this is going to be 8 plus 2, 10, 10 plus 1, 11. Now 11 is what? A is 10, B is 11. So because it's B, so I'm going to write it to be as a B. And now I'm going to basically join the two together, and I get my final answer to be as 4B. And that is what a 75 in hexadecimal is. That is how you go from ternary to hexadecimal. Now there are other methods. You might see them in book. You might see them in other teacher classes, but I can assure you that this is the most easiest one. It's fully acceptable, and it's that method where you have the lowest chances of making an error. And that's how you go from hexadecimal to ternary and ternary to hexadecimal. The chat box is now open. If there are any questions, you may ask them right now. Question, guys? Yeah, if it's clear, so I expect everyone to send the word clear. Shabash. Everyone, guys, everyone. Of course, Yusuf. So basically, हमने कल की क्लास में ये तो पढ़ा था ना कि बाइनरी से डेनरी में कैसे जाते हैं. हमने ये भी पढ़ा था डेनरी से बाइनरी में कैसे जाते हैं. अभी हमने क्या पढ़ा? हेक्साडेसिमल से बाइनरी में कैसे जाना है, एंड बाइनरी से हेक्साडेसिमल में कैसे जाना है. तो जब आपको क्वेश्चन बोले कि हेक्साडेसिमल से डेनरी में जाओ, ओके, सो द बेस्ट वे इज कि आप हेक्साडेसिमल से पहले बाइनरी में कन्वर्ट करो, एंड देन यू गो फ्रॉम बाइनरी टू डेनरी. एंड सिमिलरली अगर आपको डेनरी गिवन हो तो यू गो फ्रॉम डेनरी टू बाइनरी, एंड फिर आप बाइनरी से हेक्साडेसिमल. अभी अगर आपको थोड़ा ही कंफ्यूजिंग लग रही है इस वजह से क्योंकि आपसे कल हेक्साडेसिमल टू बाइनरी और बाइनरी से डेनरी के स्टेप्स भूल गए. अब आप जब वो नोट्स इंशाल्लाह आई एम गोना शेयर द नोट्स टुडे, आप वो रिव्यू करना, make your own notes, and you're going to understand that this is literally the halwayest tareen method you might have. Exactly, Hassan. Because that division method confusing we had, great chances of making an error. So go with this, easier, less chances of error, and a better enjoyable life for you all, right? So let's just move on. So now we have studied these three languages, number systems. Languages are both okay. Now you guys are CS students, so we're going to call them to be as number systems, right? And we studied denary, we studied binary, we studied hexadecimal. But right now we're going to look into this one important thing that, okay, it's pretty much understandable why we might have denary. It's pretty much understandable why we might have hexadecimal, what do we call it, binary. But like, why do we have hexadecimal? Like हेक्साडेसिमल को लाने का क्या मकसद है? सो हेक्साडेसिमल को लाने के जो मकासद हैं, we're going to just look into that, and that in exam usually is tested under the name of uses of hexadecimal. Now what happens is let's make a scenario where I might say that Yusuf and Hayan. So Yusuf is basically he bought himself a gaming PC. He's very happy. He's like, okay, I'm going to play RDR2, Red Dead Redemption 2. He downloads the game, and unfortunately, there is some error. error. Okay, so you might have seen those error like where x1010000897 file is missing, something like that, error code jise hum bolte hain, right? And now Yusuf Saab is sad, but then he's like, no, I know about this one very smart computer technician in our town who is Hayan. Hayan Saab is a PC technician who knows everything about computer. He's like very smart and yeah. So he has his shop, okay. And now if Ryan के पास Yusuf जाता है and Yusuf tells Hayan that, hey bro, what's up man? So I was downloading RDR2 and I got this error. So now what Hayan is gonna do, Hayan would know, okay, 897, 897 would mean error regarding RAM, computer RAM. तो मे बी आपके रैम में कोई इशू, जिस तरीके से आप कंप्यूटर लेकर जाते हो ना, जो आपके कंप्यूटर ये दुकानों में लोग को समझ आ जाती है दैट दिस एरर हैज हैपेंड, वो इन कोड से उन्हें समझ आ जाती है, राइट? इन कोड से इन्हें समझ आ जाती है. बट नाउ वी जस्ट सॉ वन थिंग. यहाँ पे इफ आई वांटेड टू कन्वर्ट दिस 8-bit बाइनरी नंबर, इट ओनली टुक मी दीस 2 digits in terms of hexadecimal. But when I was talking about it in terms of binary, वो तो इतने लंबे digits थे. So for example, अब अगर मैं कोई और error की बात करूं, let's say there is an error which says 4B. So Hayan के पास जाके Hayan is going to hear 4B. Oh, this is an error with let's say CPU. So Hayan is directly going to understand error KQ because this code is very easy to learn. It's very easy to understand. It's very easy to keep in mind. But if I replace this code with something like क्या ऊपर वाली बाइनरी थी 0 1 0 0 1 0 1 1, and now Yusuf goes and tell Hayan, bro, I got this error which has the binary 0 1 0 0 1 0 1 1. Hayan would be like, हैं भाई भाई मुझे नहीं याद, मुझे ये याद नहीं हो रहा. And like for example, there is like Hayan might memorize something like which has this 0 1 0 0 1 0 1 0. So there is a great chance, क्योंकि ये दोनों बिल्कुल सिमिलर है, बस एक 0 की जगह यहाँ पे 1 है नीचे वाले पे. तो अगर हयान को ये वाले याद हो, हयान को पता होगा दिस माइट बी लेट्स से सम इशू विद रैम, तो वो गलती में ये बोले कि भाई आपका रैम का मसला है, हालांकि यहाँ पे रैम का मसला है ही नहीं. सो द प्रॉब्लम विद बाइनरी इज कि बाइनरी को याद करना इज वेरी मुश्किल. It's not easier to understand. It's not easier to memorize. It also, if you see this exact same thing, if Yusuf wanted to tell this in terms of hexadecimal, it would have been just 4B. अब आप खुद मुझे बताओ, Yusuf के लिए would it be easier to memorize 4B or would it be easier to memorize this code? Similarly, Hayan के लिए is it going to be easier to understand 4B or this entire binary? And these are just small examples. In computers, you have big hexadecimal values like these error codes which you get. These are like x10000897. भाई इसकी जो बाइनरी होगी that's going to be literally 50-60 लेंथ की. तो क्या हयान इतना याद कर सकता है, या कोई भी ह्यूमनली बंदा इतने ज्यादा एरर्स याद कर सकता है? नहीं, राइट? He cannot. So the same reason came up when computer scientists, when they started to tell each other कि our computer has this thing, or like they wanted to tell about computer stuff, they started to share binary. And binary को understand करना was easy, not easy, it was very difficult. And likewise, binary को याद करना या लिखना used to take a lot of space. So what they did was they came up with hexadecimal, where they were like, okay, let's come up with hexadecimal where we can shorten this whole thing into just small digits like 4B. And that is more easier to understand, and it also takes less space. So that is basically the reason behind why hexadecimals were introduced. So before discussing the uses of hexadecimal, the first question that comes in our mind and should be coming in our mind, why hexadecimal? Or like, why will a software engineer or a computer scientist prefer hexadecimal? So you're going to get such questions in an exam. These are also questions the O-level kiddos aap log ko pata hona chahiye, because this is also there in your exam. So what are those common reasons? Firstly, users can easily understand hexadecimal. So memorizing 4B is very easy in comparison to memorizing this binary. Users can easily understand hexadecimal values. Understand hexadecimal values. Decimal. Let's bring this a bit down, maybe. Hexadecimal values. First point, And the second point is that if I have to write binary numbers, so binary numbers are going to take the entire space on my screen. So it's going to take the entire, so like if I have an error which is to be represented in binary, मेरे पूरे screen के ऊपर binary लिखी होगी, which is a problem because I don't want binary to be spammed over my entire screen. I want it to be short. So the second reason why computer scientists went with hexadecimal was because hexadecimal takes less space but on the screen. People usually make this blunder. Now, exam tip, okay? A lot of O-level students make this blunder too. Hexadecimal value, ये point to लिख देते कि they take less space. But bro, when you're talking about computers, you need to be very specific. Hexadecimal value takes less space. Where? In memory, on the screen, in my head, on my hand, where? So you have to be very specific. You need to say hexadecimal value takes less space on the screen. So if you miss upon this screen wala point, in most cases, they don't award you the mark. Please be super duper careful with this. Hence, I'm also highlighting that on the screen, nahi bhulna. Now to discuss where could hexadecimal be potentially used up. So the first example was just discussed. कि जनाब आपके पास बहुत से ऐसे scenarios होते हैं where when the computer has some sort of an error, it does not give you some what do we call it, binary number, this binary number error came up. They show you an error code. They show you an error code. And that error code is always written in hexadecimal. So let me show you a few examples. Let me just bring it up from, let me take a picture of this. इससे आप लोग को better understand, inshallah. But yeah. So look on to this one problem, okay? So this is from this website, Learn. Shout out to them for making it up. But look on to this. You might have seen sometimes your computer facing some problem. And at the end, you might see codes like this: 0x0000D1, 0x0000R, 0x0007, and so on. All these codes are basically in hexadecimal. Because if I were to write this in binary, जगह भी ज्यादा लेगी, लोगों को समझ भी नहीं आएगी. But अगर इनको याद करना है तो भाई, these are easier to memorize than like 50 digits for a binary number, right? So the first place where you might be able to make use of hexadecimal values are in error codes. Error codes. So in exam, they usually ask, give us places where hexadecimals could be used. So you're going to say error codes. And its description kya hogi? That hexadecimal value is used to represent the memory location of a specific error. So this basically tells me that maybe the error is there in the RAM. So it specifies the exact location. The work of it is to basically specify the location ke kahan pe error aa raha hai. So the first reason or the first usage of hexadecimal in your computer is to basically do what? Is to basically represent the memory location of a specific value. To represent the memory location of a specific error. Memory location of a specific error. Just like that, it's not only used in error codes, it's used in multiple other places too. And just as an additional point, sometimes in exam they refer to this error codes while it is as memory dump. So if anybody of you is looking onto the book or something and you see the memory dump wala point, don't be like the sir ne padhaya nahi. Memory dumps and error codes are usually the same. I prefer using error codes in exam. So that's the first place where you might want to make use of error codes. Likewise, you know, hexadecimal values. Likewise, your hexadecimal values are also used in IP addresses. Now, the students who have taken O-level computer science, you would be aware what IP addresses are. For the students who are new, let me explain you. IP address is basically a unique code that identifies your device on a network. सिंपल अल्फाज में ये कि जैसे आपका एक CNIC नंबर होता है ना जो पूरे पाकिस्तान में यूनिक है, इसी तरीके से जब आप किसी इंटरनेट से कनेक्ट होते हैं, लाइक आपने अपने PTCL के साथ 5 अकाउंट लॉगिन किए, तो वो जो 5 डिवाइसेस कनेक्ट किए, तो हर डिवाइस की यूनिक एक सीरियल नंबर होता है, यूनिक एक एड्रेस होता है, एक यूनिक उनकी आइडेंटिफिकेशन होती है. दैट यूनिक आइडेंटिफायर इज नोन एज IP address. We are going to study this in more detail afterwards, but for now the point here to understand is that it uniquely identifies your device. It uniquely identifies your device. And then IP address has a few types, okay? Identifies your device. So it's like one was the older version, and then we have a newer version. It uniquely identifies your device on the network. Now the thing is, जो older version था, that is basically known as IPv4. IP version 4. Okay, it's not like some crazy words. It's like IP address ka version 4. And then we came up with IP with version 6. Now this version 6, this basically makes use of hexadecimal values. So how does it make use of hexadecimal values? So iske under, when they are trying to comprehend values, this one IPv4 was usually in denim. So you might have seen these numbers like 192.178.10.5, numbers like this. These are basically the IP version 4 वाला, जो usually PTCL या आपके devices के ऊपर भी होते हैं. But sometimes you see IP version 6, and IP version 6 now writes it in terms of BA87 colon 7B9A colon BCA6 colon B789. And that is now representing the address, but in terms of IP version 6. But now when you make use of IP version 6, you now have letters, which means कि यहाँ पे हम maximum कहाँ तक जा सकते थे? 9 तक जा सकते थे. 9 से बड़ी चीज थी नहीं, because largest digit was a 9. Up here, you can go up to 15 वाला digit. Now 15 को अगर मैंने represent करना है, I cannot write 15, but I can write F. F means what? 15 hexadecimal. So basically this version 6 was created to extend the range of possible values. More details about this would be inshallah discussed later on. But yeah, this is everything. Now this basically uses hexadecimal, and the few differences in these वैसे आगे होंगे, but one difference is up here, they make use of full stop. Okay, they make use of full stop. Up here you see they make use of colon. Another difference is that this one basically supports up to 32 bits, which means कि यार इनके पास maximum 32 bit memory के अंदर 32 bits या 32 bits are allocated for an IPv4 address. But when you talk about IP version 6, they allocated up to 128 bits, which means that you now have a much larger space to accommodate, which is a big benefit. So now the newer world is basically shifting towards IPv6, but this is the whole point. You need to understand that IPv6 has the hexadecimal only. So if in exam you sometimes wrote IP address and आगे आपने IPv4 लिख दिया, you're gonna get a perfect zero, circular circle, right? So circular circle, circular zero, right? So if you have to talk about IP address, and that too has a usage of hexadecimal, talk about IP version 6, right? Moving on. Like just this, we also have something else known as MAC address. So now for the non-computer science kiddos, non-O-level CS kiddos, you might be confused in MAC address and IP address because they are exactly very same. Why? MAC address, it uniquely identifies your device. Now you might be saying, sir, वो जो पिछले वाला था IP address, वो भी तो uniquely identify करता है आपके device को. तो इसमें और उसमें क्या फर्क हुआ? So a simple example would be कि आपके पास एक passport होता है and एक आपके पास CNIC. Okay, you have a passport, and then you have, let's say this is passport, and then you have a CNIC. Now, if I talk about Pakistan as a world ke andar jagah, let's say this is PK, Pakistan. Inside Pakistan, if I have to uniquely identify you inside Pakistan, to aapka CNIC chahta hai. So like when you register, when you go to places, when you have to do data entry within Pakistan, you're only accepted on CNIC. Outside Pakistan, CNIC is not accepted. Outside Pakistan, CNIC is not accepted. Only passport is accepted. So the MAC address is just like your passport, whereas CNIC is just like an IP address. Why? Because IP address can uniquely identify your device, but on a single network. मतलब अगर अभी मैं PTCL के एक डिवाइस पे कनेक्टेड हूँ, PTCL के अंदर let's say my phone, my laptop, my console, my PC, my TV, let's say. So all these devices are uniquely identified within this network using an IP address. But अगर मैं पूरे दुनिया में बोलूं कि यार bro, give me that one unique number which is like literally unique to your device in this whole world, कि like अगर कोई US वाला बंदा पूछे आपके डिवाइस के बारे में, तो आप उनको IP address नहीं दोगे. You give them your MAC address. So MAC address is that unique identification number जो कि आपको पूरी दुनिया में हर जगह uniquely identify कराता है. So that's your passport. Whereas your CNIC is your IP address because it identifies you uniquely, but only within a specific region. Like Pakistan के अंदर जैसे CNIC जगह. You go to the US, you show them your CNIC and they were like, Oh hell no, mate. I don't know this. By the way, it's British, okay? But like, for example, right? You get the point. So that's how one other thing. And this MAC address, the way the MAC address works is that it is also written in terms of what do we call it? Hexadecimal value. So your MAC address might be something like 7A 9B 6D BA 987C. So this is an example of a MAC address, and you can see that there are letters, and those same letters are from the hexadecimal list, and so hence this is also a hexadecimal value. इसके अंदर आगे we're going to study more details कि यार ये क्या क्या बताते हैं, but for now your course content just specifies it till this point, right? And then the last thing where you might be making use of hexadecimals are in HTML color codes. So have you ever seen, I'm not sure if anybody of you have ever done development, but whenever you try to write some code for a color, I want this color to be red ka ye specific shade. So it's always going to represent that code in terms of hexadecimal. Kis tarah? Let me show you a picture. So let me show you a picture which has yeah, perfect. So you see up here, whenever you want to represent a color on a computer, whether that be in an application, website, kahin pe bhi, you're always going to tell the computer, okay, I want this specific shade. Ab ye sare red hai, but one is darker, the other is lighter. So scarlet, crimson, cherry red, and also sorts of colors, right? Now, the way you basically represent these colors, those are also being done in hexadecimal values. So you understand that basically you write the HTML color codes where every code is basically represented in a format like hashtag to indicate that it's a color code in higher, what do we call it? Kya naam hai? Naam hi bhul gaya. Hexadecimal format. And so you might write it to be as FF00CC. And this might denote a specific color. So whenever you write a specific color in the world of computer science and you want to tell the computer scientist here to the website, to the application, okay, I want this color, you always write the color using what do we call it, using hexadecimal values. Hexadecimal values. And generally, while developing application, you make use of this markup language, HTML. It's not like an actual language, but HTML is like a markup language. You may say, yaar, isko full authority nahi hai of being called as a language, but yeah, somewhere in there, right? So it's like you go to the US, you don't have the nationality, but you have like green card. So they aren't the same thing, but समझ, you know, likewise, HTML is not a proper language, it's a markup language. What's a markup language? Not relevant. But ये ज़हन में वैसे रखना कि HTML is not an actual language, but whenever you have to represent colors in them, you make use of them using hexadecimal values. So these are the 4 places where you generally make use of HTML, so not HTML, sorry, hexadecimal values. In exam, usually you get a question asking clear cut, give us 3 places where hexadecimals could be used. So you have to just write about any of these 3 places. मैं तो recommend करूँगा 4 के 4 याद करो, it's not that complex, हो जाएगा. But that marks the end of the hexadecimal wala topic. Now I'm opening up the chat box and I want every single one of you to let me know, are there any questions in regards to this or should we move ahead? If it is clear, I want everyone to write the word clear. Shabash. Jaldi karo. Good. Everyone. Difference between what, Yusuf? Difference between what two? HTML is like Pluto. हाँ बस समझ लो, ऐसे ही समझ लो कि HTML is like Pluto के उसको बोला यार चलो आप मार्कअप लैंग्वेज बन जाओ, आप कोई एक्चुअल लैंग्वेज नहीं, सही है. मैक एंड आईपी में आपको डिफरेंस मैंने बता दिया कि मैक एड्रेस आपकी पूरी दुनिया में आप जहां भी कंप्यूटर अपना लेकर जाओगे ना, तो वो यूनिक आपकी एक ऐसा कोड जो कि पूरी दुनिया में कहीं भी हमेशा यूनिक रहेगा. दैट्स गोना बी मैक एड्रेस. दैट्स गोना बी मैक एड्रेस. जैसे आपका पासपोर्ट नंबर है ना, आपका पासपोर्ट नंबर इज ऑलवेज यूनिक. It's like you go to the US, तब भी सही है. You go to your China, it's still unique. But आप CNIC जो आपका है वो सिर्फ पाकिस्तान के अंदर यूनिक है. आप अपने CNIC US में ले जाओ, मे बी उसी नंबर का कोई और बंदा भी मिल जाए, बट पाकिस्तान में ऐसे नहीं होता. सो आईपी एड्रेस बेसिकली वो कोड है जो कि आप जब किसी इंटरनेट से कनेक्ट होते हैं ना, तो उस इंटरनेट पे जितनी डिवाइसेस कनेक्टेड होती है उनमें से आपको इंटरनेट एक यूनिक आईडी दे देता है, क्योंकि यार आप आईडी नंबर 1 हो, आपकी आईडी 2 है, आपकी आईडी 3 है। लाइक आप स्कूल जाते हो ना एंड आपको बोल दे कि आपकी सीट नंबर 1 है, सीट नंबर 2 है, सीट नंबर 3 है, तो इट्स सिमिलर टू से कि आपकी वो क्लास के अंदर सीटिंग है। बट मैक एड्रेस इज द वन जो कि आपकी परमानेंटली, लाइक जो स्टूडेंट आईडी है जो एडमिशन के टाइम अलॉट होती है, दैट्स द मैक एड्रेस। सो यू मे assume कि जो मैक एड्रेस है दैट नेवर चेंजेस. IP address is something which always changes based upon when you code and connect with a different network. Why don't we use normal names for the color code? Because Iman, how many different names will you memorize for red? It's not only red. You have 1,000 shades of red. You have red, you have scarlet red, you have crimson red. Just go and open up Google, search for red color shades, and you're gonna get a whole list of like 20 to 30 different shades. तो उन सबको represent करने के लिए नाम नहीं याद हो सकते थे. तो we basically thought कि उनको hexadecimal value थे. How much is IGCSE syllabus different? Greatly different, greatly different. It's just like you might have one topic or maybe on max 2 topics जहाँ पे concept आपके वही होते हैं जो IGCSE या O level के, वरना everything else is new for ASO. Like permanent IP address which never changes is known as max. You may assume it to be that. Yeah, yes. So ये बाकी about this we're going to assume जो इसके related बाकी details है ना, we're going to study that later on in the upcoming topics. For now, you may just assume it to be this range. Perfect. So let's move on. So we have studied why hexadecimal is being used, where it's used, kya maqasid and everything. And right now we're going to just go into one new concept. That is that when you study 2 and 3 in school, the next thing they teach you is 2 plus 3, which is 5, right? But we aren't learning 2 and 3. We are learning zeros and ones. So the next topic, which we're going to be just studying, is basically related to binary addition. How do you add 2 binary numbers? Now I know how do you add 2 binary numbers. Hexadecimal ki addition to not relevant itna, but how do you add binary numbers? If I give you a question saying 0110 and I add it into 1010, how are you going to add it? That's the question. Because if I add it this way, 0110 1010, 0 plus 0 to chalo 0 ban gaya. 1 plus 1 is a 2. Bro, I cannot represent a 2 because there is no 2 in binary. There is no 2 in binary. So because you cannot write 2 in binary and your answer needs to be either in 0 or 1, this was a problem. And up here, computer scientists were like, okay, we sort of solved it up, but to simplify it up, we have these few rules, जो कि आप लोगों ने याद कर देने, and when you memorize them, आपके लिए बहुत आसान हो जाएगा. किस तरह? So first thing is when you add something like this, 18 plus 17, how do you do it? 8 plus 7 is, what is 8 plus 7? It's 2, 15, right? It's 15. You write 15 up here. You write 5 and you take this 1 to be as a carry. And then you do 1 plus 2 plus 3 and you write the answer as 35. When you do binary addition, उसमें भी इस तरह carries आ सकती है. So let's say अगर हम इन रूल्स को डिफाइन करना चाहें, we're going to call this as a carry, and जो हम यहाँ पे लिखेंगे इस जगह पे, that is let's say our answer. Okay, so we're going to study कि जब हम क्या क्या ऐड करेंगे तो what could be the answer, and what if I add 2 things, can I get a carry out of it or not? So let's do it. So we have the digits up here. So possible cases of addition are that you add 0 with 0, like जैसे हमने यहाँ पे किया 0 plus 0, or you have a case where you do 0 being added into 1, something like this. Or you might have a case where you do 1 being added into 0, something like this. Or you might have the case of 1 being added into 1. And of course, you also have this one case where 1 is being added into 1 and then that is again added into 1. So these are 5 rules which you need to memorize, where we are going to learn कि यार इन सब के लिए हमारा आंसर क्या आएगा and will it result in any sort of carry or not. So this is something which you might find a bit confusing if you're studying it for the first time, but with a bit of practice, I can assure you that you're going to love it. Okay, so the rules are pretty straightforward. When you add 0 plus 0, the answer is also 0. So like you write a 0 up here the way we do up here, and there is no carry at all. So it's like just if I do something like 17 plus 2, so 17 plus 2 is 19. I write 9, 1. There is no need of carry. So यहाँ पे carry 0 है. There is nothing up here, right? Similarly, we say that the carry is basically 0. No need of having a carry at all. Then if you add 0 with 1, so when you add 0 plus 1, the answer is going to be 1. And of course, no carry at all. Similarly, this is just the opposite of that. You just flipped it up. 0 plus 1 is same as 1 plus 0. So 1 plus 0 is again going to be 1, and there is going to be no carry. The problem comes up when you add 1 plus 1. 1 plus 1 you cannot write 2. So when you add 1 plus 1, you write the answer to be as a 0, but you bring up 1 carry. So like up here I did 1 plus 1, right? So the answer I thought was going to be 2. But now if I have to add them up, I'm not going to do it this way. What I'm going to do is I'm going to write the answer, this answer to be as 0 up here. And I'm going to bring 1 carry up here. So मेरे पास ऊपर चलेगी carry. And then we're going to continue कि कैसे होते हैं वो मैं आपको समझाता हूँ. But right now this is the logic. And if you add 1 plus 1 plus 1, you might be saying, sir, ये क्या scenario आ गया? 1 plus 1 plus 1 light चली गई. But yeah, this is, for example, if this question was something like this. You have 1 carry. So like this one basically came from the carry. And these two are ये दो. So if you have a carry plus 1 plus 1, उस case में sir क्या होगा? So उस case में you need to have your answer as 1, 2 and your carry as 1, 2. And these are the set of rules which you're going to use to basically solve questions where you have to add binary numbers. So now let's do a bit practice of it, okay? So we're going to do a bit of practice. And with practice, you're going to automatically memorize these rules, inshallah, on your own. Don't worry. So there is a binary number, let's say 0010. And you add it into, let's say, 1001. Simple. So 0 plus 1 is what? 0 plus 1 is 1. So you just write 1 up here. Done. No carry at all. You move to the next one. 1 plus 0. 1 plus 0 is what? Answer is 1. No carry. So you just write 1 up here. Then 0 plus 0. Answer is 0. Carry be 0. 0. And 0 plus 1. Answer is 1. Carry 0. So I get the answer as this. Now, if I have to do it even in denary, like ye karna nahi hai, but let's say I want to verify my answers. So this was 1, 2, 4, 8. This is 2 plus, and this was what? This is 9. So 9 plus 2, this should give me an answer as 11 up here. So this is 8 plus 2, 10, 10 plus 1, 11. Hence, it's verified that yes, my calculation was correct. Now, you don't have to verify it, but this is just for your own understanding. कि when you add binary numbers, it's like what denary में भी same to same उसी तरीके से addition हो रही होती है. Likewise, if I make you guys solve this other question, let's say we have a question up here saying 1001 0011. This is the scenario. Now you have to add these numbers. So back to the rules. The first one says 1 plus 1. So 1 plus 1 is basically the answer is a 0 and a carry is going to be 1. So I'm going to write the answer to be as a 0. So in dono ke niche mein 0 likh dunga. And I see I get a carry. So you have a carry up here. Now you might be saying, sir, 1 plus 0 plus 1 ka to aapne nahi kara hai. So now when you get a scenario like this, it's basically 1 plus 0 plus 1 is basically the same as saying 1 plus 1. Why? Because aap 1 and 0 ko let's say add karo. What's the answer going to be? 1 plus 0 is what? 1 plus 0 is a 1. So 1 plus 0 plus 1 can be written as 1 plus 1, 2. So if I have 1 plus 0 plus 1, this is the same way if I have to focus upon 1 plus 1, 1. So 1 plus 1 is this, where your answer is 0 and carry is going to be 1. So I'm going to write the answer to be as a 0. And I bring up a carry. Same up here. Now you have 1 plus 0 plus 0. Now in this case, 1 plus 0 is what? It's a 1. So we come back to this 1 plus 0 logic. So 1 plus 0 says answer as 1 and carry as 0. So 1 plus 0 means 1 as an answer. And this 0 is 0 thoda left place. And 0 as carry. So this comes up here. And 1 plus 0 is 1 plus 0. You just write the answer. And boom, I got my answer to be as 1, 1, 0, 0. Convert karo to verify 1, 2, 4, 8. 8 plus 1, 9. And 2 plus 1, 3. This should be 12. So 8 plus 4. And yes, it is 12. So you see, I got the exact correct answer. This verification is not required on your exam paper unless asked. But this is for your own ease. Agar aapne kabhi verify ya kuch karana ho ya koi is tarah question ho, you are getting confused, you can always verify it this way. But that's how you basically add binary numbers. If I have to continue with a bit of longer numbers, some bigger numbers, something like 1, 0, 0, या बल्कि चलो 0 1 0 0 1 0 1 0. Adding 1 2 3 4 5 6 7 8. Add it into 1 0 1 1 0 0 1 1. Let's add them up. So if I add them up, the first number, and I can also copy these rules for you all to simplify the whole thing. So I'm going to copy these whole rules for you. I'm going to bring them down together. तो थोड़ा सा छोटा कर दूंगा. I'm going to store them up here. And now you're going to look onto the rules and solve it. So 0 plus 1 is basically this one. You write the answer to be as a 1 and the carry as a 0. So you write 1 up here with no carry. The second is 1 plus 1. So you do 1 plus 1. 1 plus 1 means answer is 0. Carry is going to be 1. So 1 plus 1, answer as 0, carry as 1. Now comes up this longer one, 1 plus 0 plus 0. So 1 plus 0 is a 1. That's being added into 0. So same to same, ye wale aage 1 plus 0. You write the answer to be as a 1 with no carry. Then the next one is 1 plus 0. Simple. 1 plus 0 is 1 with no carry. 0 plus 1, simple. 0 plus 1, answer as 1, carry as 0. Same to same, 0 plus 1, just the same. 1 plus 0, same. 0 plus 1, same. And you see, I just got my answer. That's how you basically add these values. That's how you basically add and basically manipulate these binary values. But now sometimes you also have, like, for example, if I make you do some complex question, being added into something like this. Let's do it this way. This might be a bit confusing. Why? Because 0 plus 0 is a 0. Go to say 1 plus 1 is a 0. We get 1 carry. 1 plus 0, same as 1 plus 0. So you just write the answer as 1. 1 plus 1 is now a 0 with 1 carry. 1 plus 0 plus 1 is 1 plus 1 एक दफा फिर से, right? So same 1 plus 1, answer is going to be 0 and carry आपके पास 1 आ गई. Then 1 plus 1 plus 0 is same as saying 1 plus 1. You write the answer to be as 0 and you bring up 1 carry. Carry आपके पास यहाँ आ गई. Now it's the special case. 1 plus 1 plus 1. So 1 plus 1 plus 1. This means answer be 1 and carry be 1. But now in this case, 1 plus 0 plus 1 is the same as saying 1 plus 1, right? And when I do 1 plus 1, I write the answer as 0, but we always have 1 carry. Now ye carry kidhar jayegi? Ye carry kidhar jayegi? That's the concept which we are going to study right now. This carry has to be brought down. Like you have to write it down up here as 1. Thoda sa gap dekhi, you have to write it. But the problem is, if you remember the specific register which we were studying and the devices which we are like the memory stuff which we were discussing in the last class, we might have something like this. So ye to 8 slots ko accommodate karte na. So for example, if I copy this thing for you all, if I copy this thing, bring it down here, oh my god, I bring this down here and I have to, let's say, put this somewhere up here, remove the previous stuff, okay? And you might want to store because your baki values 8 bits thi. These were 8. The niche value were also 8. So I expect it's going to be the answer has to be in 8 too. But if I remove them, you're going to see that unfortunately this new answer cannot get fit in. So I'm going to start from the right hand side. 0 0, oh my god, this is a 0 1 0 0 0 1 0. And so this 1, it has no space. It has no space. So when you add two numbers, that result in an answer that is greater than the maximum that could be stored in an 8-bit register. Like इसमें maximum कितने size की चीज store हो सकती है? कैसे पता लगेगा? If I make all of them 1, that's going to tell me कि like इसमें maximum इतनी value store हो सकती है. For example, and when I add all of them, the answer I get is basically 255. So when you add two numbers that results in the answer being greater than 255, then understand that that can not longer be fit in 8 bits. But because we don't have more than 8 bits up here, like हमारे पास तो ये 8 bits की जगह है, so we have this one brought down, but this thing, basically this process where you have an error like this being caused, where a 9th bit has been created due to carry, जिसके लिए हमारे पास जगह नहीं है, that is known as an overflow. Similar to saying कि यार आप पानी की टैंकी को भर रहे, आपके पास टैंकी में इतनी जगह थी, बट आपने इस तरह किया कि आपने 10 बाल्टियां ऊपर से डाल दी एंड आपको लगा फुल हो जाएगा इसके अंदर ही, बट It did not get into it, so it overflew. So पानी बाहर गिर गया, overflow हो गया. हम कहते नहीं पानी overflow हो गया यार, पानी की मशीन बंद करो. So this same thing comes in the binary world too. Now when you add binary values, if it results in an answer that is greater than the maximum that could be stored in an 8-bit register, what do we mean? Like इसको अगर मैं अभी binary में convert, denary में convert करूँ, the answer definitely is going to be greater than 255, and that means that it can no longer be accommodated in these 8-bit register. So either we need a bigger register. 8-bit से बड़ा क्या रजिस्टर होगा? It's going to be a 12-bit register. 12-bit से क्या होगा बड़ा? 16-bit. 16 से बड़ा क्या होगा? 32, 64, 128 bits, and so on. ये चलता जाता है. But if I'm only talking about this case, when you add two binary values and it results in an answer that is greater than 255, that could be maximum stored in an 8-bit register, you have this one extra carry being created, which you are going to bring down. Answer में ये लिखना है. There's going to be mark for this, and this error that has been caused is basically an overflow error, because you have this new bit overflowed than the maximum you could have basically generated. Another question which I'm going to solve, and then I'm going to take your questions, and that's going to be 1 0 1 1 0 0 1 1 being added into 0 1 1 1 0 1 0 1. So you have to add them, and we're going to see इससे हमारे पास क्या आंसर आता है. So if I look back onto the rules too alongside, I can clearly see. So yeah, if I look onto the rules, 1 plus 1 is basically a 0 with 1 carry. Then 1 plus 1 plus 0, it's similar to say 1 plus 1 plus 0. It's like the same as 1 plus 1. This is going to be a 1 on its own. So 1 plus 1 is again 0 with 1 carry. Same to same, 1 plus 1, 0 with 1 carry. 1 plus 0 is as if 1 plus 0. So that's going to be 1, because we know answer 1, carry 0. Then 1 plus 1, 0 with 1 carry. And now 1 plus 1 plus 1, ये वाली है. So it's going to be answer be 1, carry be 1. And now again 1 plus 0 plus 1 is same as saying कि हमारे पास answer तो आप 0 लिखोगे, but you get 1 carry. And right now 1 plus 1 plus 0 is again as 1 plus 1, where you might say the answer is going to be a 0, but you get 1 additional bit. So in exam, you're going to show this carry, definitely show this carry, put up an arrow like this and write this 1 next to it, and then you make an arrow and you write overflow. That is how you indicate in your exam ki overflow error. And usually you get it like for a 3 or like maybe 4 mark question on this, where you have to show all your working. So all the question usually asks you to show all your working. And when you're expected to show all your working, this means कि यार, if anybody thinks कि यार सर मुझे याद था carries नहीं लिखी, या मतलब ये arrow में 1 नहीं लिखा, but like answer तो वही आ रहा था ना, you won't be getting full marks. So keep this in your mind, that whenever you have carries and stuff like this, you're going to show it this way so that you get the full, either if it's a 3-marker question, 3 marks, and if you ever have an overflow question, तो उसमें overflow का भी 1 mark होता है. So you have to show it this way to get a 4 mark. And that is how you basically add binary values with each other. These are the rules, and that is how you basically add them. And if you add it in a way where if you only had the register of 8 bits, or like you were dealing with 8 bits slots, memory location, and the answer was something greater than the maximum that could be accommodated in 8 bits, then that's going to result in an overflow error, which we just saw कि इस तरीके से आपके पास वो carry के form पे आ जाता है. And that is everything you need to know for binary addition. So the chat box is now open. If there are any questions, ask off so that you. Sir, you say that computer don't store data more than 8 bits, and I'm like, then how are computers able? नहीं, ये हमारे केस में 8 bits है. हम ये जो क्वेश्चन के अंदर देख रहे हैं ना, ये बेसिकली कंप्यूटर इस तरह की मेमोरी लोकेशंस की बात कर रहे हैं. तो अगर हम ये बोलना चाह रहे हैं सिंपल अल्फाज में, आपकी बात सही है. इट्स नॉट लाइक कि योर कंप्यूटर इज ऑलवेज गोना हैव 8 bits. इन रियलिटी द कंप्यूटर्स वी हैव टुडे, दे हैव 256 bits, 512 bits. वो एक्सट्रीमली बड़े होते हैं. The case which we are currently dealing, it's like आपके पास ये एक पानी का टैंक है, टैंक 1, एंड फिर आपको बोला जाए कि इसी तरीके से एक दूसरा है जो कि टैंक 2 है, जिसके अंदर 80 स्लॉट्स हैं, एंड आप वो दोनों ऐड करते हैं, एंड यू वांट टू पुट इट इन द सेम 8 स्लॉट्स. तो क्या उसकी जगह जब हमारे पास नहीं होगी तो आपका हमेशा ओवरफ्लो हो जाएगा ना. तो वो आपको समझाने का बेसिक मकसद ये है कि अगर आपके पास कैपेसिटी विच इन आवर सिलेबस, ए लेवल सिलेबस, इट्स यूजुअली गोइंग टू बी 8 bit रजिस्टर, तो वो बेसिकली इस तरह हो जाएगा. नाउ इफ इट वाज समथिंग बिग, if I say that our case was something big, like we talked about 8-bit registers till now, but it might be even bigger. So like, let me put it up here. It can further go on. So like right now we were just dealing with 8 bits, because usually it's 8 bits, but you can also, it's like further extendable. It's not like 8-bit पे ये बस हो जाती है. So it's like 8, you then go to 12, 9, 10, 11 and 12. And उनकी values भी इसी तरीके से पिछले वाले से double होती है. So next one is 256, double of this, then double 512, then double 1224, and then double 2048. Now if the question had the value in 12 bits, फिर तो मसला ही ना होता, क्योंकि ये ओवरफ्लो जो हमारे पास आता, तो इस ओवरफ्लो को के लिए हमारे पास जगह थी, राइट? सो लाइक इफ आई हैड टू राइट इट अप, it would have been this way. So let me show you. It is this, it is this, it is this, and you can see 0 0 0 1 0 1 0 0, and now you see कि यहां तक तो मेरे 8 बिट्स की जगह थी. This was my 8-bit वाला जगह. But now if the question was like of 12 bits where we had extra space, which usually overflow questions में वो आपको नहीं देते. So but if the register comes up with a 12-bit, which the fact up here is that it varies by size, register के size के ऊपर. So it's like that you have one की जगह, so you write one up here, and the other places which are like you don't have anything, you just put zeros, because you have empty zeros, they make no difference. But now you see, right now there is no overflow, because you had the space, you had space up to maximum of 2048, और ये सारा add करो, so you had like 3000 वाली जगह. But in this 8-bit वाले में you only have जगह of up to 255. So it depends upon the question, and you generally have like a register size. But if the register usually in exams is of 8 bits, तो हम इसको यूजुअली इसलिए आपकी क्वेश्चंस में हम 8 बिट्स कराते हैं, क्योंकि एग्जामिनर ने जब ये आपको टेस्ट करना होता है तो एग्जामिनर कभी आपको 12 बिट नहीं देता. द ओनली वे टू सॉल्व एन ओवरफ्लो एरर इज कि अगर आपका ओवरफ्लो एरर आ रहा है तो जो आपके मेमोरी के अंदर रजिस्टर का साइज है, इफ दैट्स 8 बिट, मेक इट 12 बिट. When you increase the size, तो वो आपका automatically it got accommodated. So you increase the size. कि मतलब आपने 2 पानी की बोतलें गिरा दी एक बोतल के अंदर, तो अब आपके पास वो फुल हो गई. The only way to solve the overflowing error is कि यार आप उससे भी बड़ा मग ले आओ या आप बड़ा जग ले आओ जिसके अंदर आप डाल सको. So the only way to solve an overflow error is that by increasing the capacity of a register. इसके बगैर कोई तरीके नहीं. Sir, we can also consider 2s10 and 3s11. 2s10 and 3s11. किस तरीके से जवेरी, I didn't get your point. आप किस की बात करें, मतलब किस तरीके से you want to consider 2s10 and 3s11? ईमान एंड यूसुफ, आपके क्वेश्चंस क्लियर हो गए, राइट? जवेरिया, टेल मी, आर यू टॉकिंग अबाउट द बाइनरी एडिशन या किस चीज में? परफेक्ट ईमान. यूसुफ, क्लियर ना कि ओवरफ्लो को सॉल्व करने का क्या तरीका है? इंक्रीज द, if 1 plus 1 is 2, so can we consider 2 as 1 0? नहीं, you cannot. आपने हमेशा उसको 0 और 1 में एक में लाना होता है, तो इसलिए आपके लिए इन्हीं रूल्स को आपने फॉलो करना होता है. इसके बगैर आप कोई रूल्स नहीं फॉलो कर सकते. सही है? सो ये रूल्स आपने याद ही करने हैं सॉर्ट ऑफ, इसके बगैर कोई तरीका नहीं. यूसुफ, आपने पूछा कि सर ओवरफ्लो एरर को सॉल्व करने का कोई तरीका है, तो तरीका ये है कि आपको मैं एक बात बोलूं कि आपके पास एक पानी की बोतल है जिसके अंदर 200 मिलीलीटर आ सकता है, आपके पास दूसरे पानी की बोतल है उसमें भी 200 मिलीलीटर आ सकते हैं. आपने इनको डालना है एक जग के अंदर, बट जग की कैपेसिटी इज ओनली 300 मिलीलीटर. तो आपने इन दोनों को जब इसके अंदर डाला, तो क्या ये इसके अंदर फिट हो सकता है? नहीं, राइट, नहीं फिट हो सकता. सो इट्स गोना ओवरफ्लो. सो बाइनरी के अंदर जब ओवरफ्लो होते हैं, तो इस सिनेरियो को अगर यहाँ पे भी ओवरफ्लो हो रहा है, इसका सोल्यूशन क्या है? The only solution is कि यार इस जग की जगह अगर मैं 300 करूं, इसका मैं 500 ml के साथ रिप्लेस कर देता हूं ताकि पानी इससे ओवरफ्लो ना हो. So when you have binary के अंदर overflow coming up, the only thing, the reason is कि जो आपके पास जग होता है उसका साइज होता है 8 bits. Like it's a smaller register. The capacity of it is only of 8 bits. और 8 bits की maximum capacity is always 255. How do you get this 255? आप सारे रजिस्टर में सारे 1 1 1 1 1 कर दो, एड अप करो, 255 बन जाता है. So the maximum capacity you have is at 255, but that is of 8 bit, like जो कि आपके छोटे वाला जग है. तो लाइक अगर उस पर फिट नहीं होता तो मैं बड़ा वाला जग ले आ सकता हूँ, बट एग्जाम में आपको नहीं लाना होगा, ये वैसे ही आपको कॉन्सेप्चुअली समझा रहा हूँ। एग्जाम में यूजुअली यू आर गोना बी गिवन 8 बिट नंबर, एंड हमें कैसे पता लगना है कि हमारे पास रजिस्टर 12 बिट का है या 8 बिट का? आप काउंट करो, if you are given 8 binary numbers, this means कि you have a 8 bit register. अगर आप काउंट करो and you have something like 0 0 0 1 0 0 1 0 1 0 0 1, इनको काउंट करो 12. So now I know that my answer is going to be written in a 12-bit register. Now 12-bit register में then there is extra space. The way I see कि यहाँ पे मेरे पास 500 मिलीलीटर है, तो जो ओवरफ्लो पहले हो रहा था वो अब नहीं होगा क्योंकि मेरे रजिस्टर का साइज बढ़ गया. बट एग्जाम में दे आर ऑलवेज मोस्ट प्रोबेबली गोना बी गिविंग यू 8-bit register, एंड आपको कैसे पता लगना है? जस्ट काउंट द नंबर ऑफ बाइनरी डिजिट्स. रजिस्टर की डेफिनेशन सिंपल अल्फाज में है कि इट्स बेसिकली आपके मेमोरी स्लॉट जिसके अंदर आपकी बाइनरी वैल्यू स्टोर होती है. सर इफ आवर आंसर कम्स इन अ 10 bit, so we can't do anything and instead mention it as overflow. 10 bit तो पहली बात होता ही नहीं है. 10 bit कहाँ से आया? 10 बिट आपके ये फर्स्ट बिट, सेकंड, थर्ड, फोर्थ, फिफ्थ, सिक्स, सेवन, एट, 9th बिट होते हैं. तो अगर आपके 9th बिट में आ जाता है, आप इस तरह एक एरो लगा के नीचे 1 लिख देते हो एंड यू जस्ट इंडिकेट दैट इट्स एन ओवरफ्लो. एग्जाम में आपने लिखा. क्लियर यूसुफ? ईमान रजिस्टर इज बेसिकली इन वेरी सिंपल अल्फाज अ मेमोरी के अंदर स्टोरेज पीस जिसके अंदर बाइनरी वैल्यू स्टोर हो सके. इससे ज्यादा आपको कुछ पता नहीं. बस सिंपली जहां पे बाइनरी वैल्यू स्टोर होती है ना, तो उसके लिए जो हमने मेमोरी में जगह दी हुई है, दैट इज नोन एज अ रजिस्टर. Perfect. That's great. बाकी सबको भी क्लियर हो गया? Every single one of you, please message the word clear in the chat box so that I understand. Okay, perfectly great. So that basically marks the end of our today's class. That marks the end of our demo series too. And I hope it was a good session. Just like this, we're going to continue, inshallah, from our next class, which is going to be on Friday. So for anybody who might be interested in registering, you can contact Ma'am Naiba on this number, +92 318 177 2015, and you can register for our demo for our AS level classes. I guess we do have an early bird deadline till the end of the month, so you can contact Miss Naiba, वो आपको बाकी बता देंगी. And yes, register students वाला group कब बनेगा? वो बनेगा इंशाल्लाह in the next few days. तो 2-3 दिनों तक बन जाएगा इंशाल्लाह. So before the next class, so before Friday इंशाल्लाह. सर आपको नंबर याद हो गया, जो बात है नंबर याद ही होगी. सर एयर प्राइवेट्स के ड्रॉबैक्स डिस्क्लोज करते हैं एंड व्हाट आर द एडवांटेजेस इफ वन वांट टू गो फॉर यूनिवर्सिटी. ड्रॉबैक सिर्फ आपका ये होता है कि आपके पास काउंसलर नहीं होता, एंड सेकंड ड्रॉबैक ये होता है कि आप नए दोस्त नहीं बनाते. थर्ड ड्रॉबैक ये होता है आप स्टूडेंट काउंसिल में नहीं जा सकते, एक्स्ट्रा करिकुलर्स आपकी मिनिमल हो जाती है. तो ये 3 मेजर ड्रॉबैक्स अगर आप यूनिवर्सिटी के पॉइंट ऑफ व्यू से पूछो, बिकॉज फॉर अ यूनिवर्सिटी स्टूडेंट काउंसिल मींस अ लॉट. You are the head boy of your school, end level importance. You are leading the STEM club, you're the president of the debating society, बहुत value है इस चीज की. You are the secretary general of a MUN, value है. When I got my acceptance from US in Case Western, the dean of admission wrote this message on my acceptance letter saying that we are really impressed from your achievements in MUN because I'm a crazy manner. Okay, I do MUNs a lot. So क्या नाम है कि what do we call it, तो उन्होंने लिखा था कि we would love to have you in our MUN team. तो इस तरीके से आपको ये चीजें जब होती है, they add up a lot of stuff. सही है? So if you miss upon this, तो ये थोड़ा सा आपका मसला होता है. So now the entrance test for LUMS, NUST, FAST based on the OA level syllabus. LUMS का entrance test नहीं होता. If you go with SAT, you are exempted. NUST and FAST का आपका FSC के syllabus के ऊपर होता है. And no, I will not recommend FSC at all, especially for sciences. Never, never, never वो हो जाती है. वो syllabus content same होता है, थोड़ा सा ही आपका वो different हो जाता है, तो आपको आगे वो हो जाता है. आप end time में books उनकी use करते हैं तो good scene हो जाता है. But the conceptual understanding you get in A levels, unbeatable. लास्ट डेमो क्लास पे आपने अब मुश्किल टॉपिक्स लाना शुरू कर दिए. ये तो अभी, ये आप डरो मत, ये पता है आपके पास अभी रिकॉर्डिंग अवेलेबल होगी. अब हम आपको पूरे 5 दिन क्यों दे रहे हैं यूसुफ? आपको हम 5 दिन क्यों दे रहे हैं? हफ्ते में 3 क्लासेस क्यों होंगी? 3 या 4 क्यों होंगी? द रीजन इज कि 3 या 4 दिन हम आपको नया पढ़ाएंगे, जो बिफोर बाकी के 3-4 दिन है उनमें आपने यही रिकॉर्डिंग फिर देखनी है। अगर समझनी है आपने नोट्स खुद बनाने, अभी आप जाके इसी रिकॉर्डिंग को फिर से देखोगे एंड यू कैन अंडरस्टैंड एवरीथिंग इन ग्रेट डिटेल। एंड ये जो प्रैक्टिस है ये आप प्रैक्टिस से सीखोगे। सो इंशाल्लाह वंस यू रजिस्टर, द रजिस्टर क्लासेस के अंदर जो हमारे पास प्रैक्टिस सेशंस होंगे वो हर वीक कंडक्ट करेगा बाय माय टीए। सो व्हेन माय टीए कंडक्ट्स दोस प्रैक्टिस क्लासेस, तो आपको हर वीक का कॉन्सेप्ट ऑटोमेटिकली और ज्यादा कंफर्म एंड यू नो सॉर्ट ऑफ मेमोराइज होता जाएगा। सो यू विल बी मच मोर गुड। क्या करें सिर्फ, और स्कूल डोंट हैव दीस क्लब्स एंड ऑल, खुद बनाओ, खुद अपने क्लब बनाओ, become the founder. You don't need your school approval letter. Go join, ask a few friends of yours, come up with a club, ask your juniors कि okay हम session कराना चाहते हैं, make some projects, and boom, on your application go list down that I'm the founder of the STEM club, something like that. People do it, and that's even way better. So how many amigos मैंने काफी किया हुआ है यार बस. Right now I'm a part of Lumen too. So if you're a manner, you might know about Lumen. I'm also part of Lumen. I was Lumen Dice last day, last time. 3 days new concept, 3 days revision by yourself, 1 day practice with you. Exact. Bilkul Yusuf, you got. But Hayan, I've done, I don't know, maybe 15 years to be, yeah, 15K get ambience. You can form a club. Of course you can. Of course you can. You're going to be direct the president. But then it's not only about forming the club. आपने काम भी करना है. Take those sessions, guide people, make projects. All of those stuff are going to, what do we call it, add up. रिकॉर्डिंग तो यूट्यूब पे अवेलेबल नहीं होगी अनफॉर्चुनेटली. मे बी अगर कोई एक आध टॉपिक की अपलोड हो जाए, बट नहीं, इट्स नॉट गोना बी लाइक कि आपको पूरा सेशन अपलोड होगा. But yeah, that is it for today, everybody. I'm gonna write my WhatsApp number too. If anybody wants any help with anything, या फिर कोई recommendation, या still you are unable to decide, just reach out to me. मैं guide कर दूंगा आपको इंशाल्लाह. सही है. And see you guys inshallah in the registered classes if you decide on joining us. I hope so inshallah. But that is it for today. I have 10 minutes before my O-level class. Take care. See you guys inshallah in the registered class, and Allah Hafiz.